So hi guys, this is Rudy this side, and I'm really excited to show you all what I have built as a submission to my assignment for the invoice API in Rust. So let's start. Let me give you a brief of how the overall system is designed. Okay, so this is the design document. Okay, so we can see like I've kept the data model really simple. We have a data set, we have a model of businesses which can maintain like how many businesses are there with their name and timestamps they are created at. For each businesses, we have their API keys, like what API keys they are actually issuing and at the timestamp, so that we can later on, if we scale, we can get the audit logs and that can be used. Okay, we have our customers. We each businesses have to have their customers, so they have their customer data set in which they can have all the data related to their customers. Okay, the customers would be linked via a UUID business ID. Okay, that's pretty simple. And each customer would then receive an invoice which would be issued by the businesses themselves. So the invoices would contain all the data like what are the payment you have to make, what is the invoice state, is it paid, is it not paid, all the other states, and the due dates of the invoice. Okay. And for each invoice, we have invoice ID, description, unit amounts, and all other stuff. And payment attempts are also attached. Like this is another add-on which I have not developed yet, but this can be used in earlier version when we would be developing refund systems, right? So they have their payment attempts, and in for each payment refunds, the refunds are also there. And for payment attempts, let's suppose if some payments are not in the retry queue, like they have surpassed the retry limits, they can be added in a dead queue. So that's also considered when I was designing this overall system. Okay, so that when we were getting audit logs and when we are actually seeing the things like what's the issue in the system, we can see from the dead queue, it's dead letter queue, DLQ, what is the actual issue. Now, talking about the webhooks are simply used for steering notifications to businesses like, hey, your in this invoice has been cleared by the customer, or what is current invoice status. That could be done by webhooks in real time. So for webhooks, we have been using this all data sets. But a quick note: when we are scaling, one thing which can be done is like we can use queue systems. That would be more efficient for webhooks to transmit messages and for multiple businesses. Like if we have a couple of hundreds and thousands of businesses in the system, to manage them all, we should be better using some service like Kafka or AWS SQS for better management of the webhook deliveries, right? So that has been considered when I was designing this document. And this is a complete like talking about the invoice state machine. Each invoice has a has a state of its own. Like is it when it's open, when it's paid, when it's void, or when it's uncollectible. Okay, so this is reserved for future dunning. Post invoices, you can null and void a complete invoice. Okay, if an invoice is payment succeeded, so all the options are there. Like open is there, invoice is created. Okay, invoice is paid, PSP success, yes. And invoice has been void, explicit void API, terminal, yes. Reversible transitions, none. Terminal states are immutable. Okay, and these all are like idempotent. So if let's suppose I have changed the state of one invoice to paid, I cannot again change it to same or like other invoice linked to that same ID. So I have kept the care of idempotency as well. And talking about the correctness and failure measures, I have developed some test cases for concurrency. So we have concurrent mechanisms. Okay, we you can read this complete doc. It's all the things are mentioned there. Okay, we have two concurrent post and pay on the same invoice. Both requests serialize on invoice or log. Okay, and idempotency is also there. Post pay on paid invoice, and webhook design is also like there. Like for webhook, as I have said earlier, we have dead letter queues. So if in case we have like some webhook deliveries are dead, they can have a local dead letter queue, and the reconciliation job is done periodically to scan the dead deliveries. Okay, so that in future we can add more better debugging strategies when we are scaling. Okay, that's added upon. Refund pipeline design. One thing which I have designed but it's not developed in this system is a refund pipeline. So for refunds, we would be having a similar state machine when I was ideating. like when someone would post refund, it would be requested. A worker would claim the refund from the system. It would take the state from processing, and it will investigate the changes, like if the PSP fund is succeeded, it would make it succeed. If some due to timeout or safe retry, it would require reconciliation. It would do the reconciliation methods, and then the PSP would confirm that it is refunded. If PSP refund is rejected, PSP confirms not refunded, it's failed. Sometime it's cancelled before the PSP call, so it's cancelled. So all the states are managed for the refund as well, and refund is like 1 euro per refund request, and all other things have been taken care of. And webhook events also should be created, like if a refund is created, succeeded or failed, for all the complete life cycle of the webhooks. Okay, talking about the API key model, like you can simply just generate an API key in this particular code base. I have hard coded the API keys, like you can get them from the readme.doc, and you can use that API key other than generating your own for the simplicity sake. Simple. And rotation, issue new API key to via admin endpoint, not build, revocation, blast areas. Okay, all other things have been taken care again, and some things which are like cut, why they are cut. Okay, the reason is simply refund API implementation. It's above of the MVP scope. Okay, and subscriptions and recurring billing, that's a complete product surface entirely. We need to integrate a lot of stuff. Multi-currency tax, we have only kept to USD cents only. Rate limiting, production gaps it is, but we it's can it for this demo, rate limiting is not that much required. Email notifications, webhooks are there for notifications, but integrating an email part to that does not make a lot of sense, because we are not going to test that anyway. Okay, so these are the production gaps, and this is the basic system design which I have developed. Okay, now talking about the how the code base actually looks like, and giving a complete complete gist of how the code looks. So let me just share my screen. Yeah, so here is our code base. We have an invoice service which has all the authentication methods. Okay, it completely takes care of the authentication. Auth middleware is developed. We have a domain which manages all the invoice states, like how the invoices are managed, and payment attempt statuses, and webhook delivery statuses is managed. Then we have our PSP, payment service clients, and it also manages all the payment service, like how the PSP charge responses, their PSP outcomes, and all other that stuff. Routes are there to interact with if you have to add customers, delete some customers, if you have to add issue new invoices to your existing customer set. Okay, etc. Then we have pay. If you have to pay a certain invoice, it's also there with all the failure test cases. Webhooks are developed, like you can interact with the webhooks in the real time. Again, this is the webhooks code. Like in this case, we have developed our queue on our own, but when in production cases, it is highly advised, like we integrate some service like Kafka, RabbitMQ, BullMQ, or other such service for proper management and queues of webhooks. Okay, and these are the workers, these are the reconciliation workers which get the things done on retry and all other things. These are the reconciliation workers, and these are basic like claim, config, and other that stuff. And talking about the mock PSP, this is just a simple line of code which for which I have used a lot of AI. Okay, it's basically managed for payment service providers, and it's really basic. Okay, so this is a mock PSP. And talking about the usage of AI in this particular project, the system design has been ideated by me. Like I have used some AI for reading about the concepts and brushing upon my concepts. Okay, of course, but for the coding part, I have implemented a basic boilerplate using Claude and Cursor, which I have. Okay, so that I can integrate all the stuff, like for developing exam routes, SQLX migrations, and all other stuff. I have used Claude. Then Cursor autocomplete is used, of course, for like boilerplate and search structs and all other that part. Talking about decisions which I have to make is like invoice is created in open state, not draft. like it's a simple like API surface, and for limiting the user confusion, because draft would mean like it's still in a written phase, open would mean like the invoice is issued, and it's now open to any, and it's now open for, it's now issued to a consumer, so it should be paid. Okay, that's the thing. And row lock and in-flight attempt guard, like this has been like AI has leaned towards serializable transactions globally, but I chose like for select for update on the invoice so plus rejecting duplicate processing. Okay, so narrowing down the things has been done by AI 202 accepted. I mean basic things have been like decision by me, and some things which AI have gone wrong, this has been like I have to check that up in the API key itself. And something which I have to review manually were like I-64 cents, like all money paths should be using I-64, not floats. Idempotency, replay path return stored JSON without a second PSP call. Concurrent pay test results exactly 200 OK and 9409 conflict responses, and worker replay intervals. So this is my submission for this particular assignment, and I hope you guys like it. So this is Rudy this side, and yeah, thank you.